Yeah. So we did this thing. So super mesh we have done. Today the problem that we'll do, that will also be an example of super mesh. Go into nodal. Super mesh we saw this dependent source. I think dependent source also. Yeah, this we have done. Now next we will do a problem which combines these both things. That means this super mesh concept and also the concept of this dependent current source. Okay, so both you have to use here to solve this problem. So the circuit you can see. Let me just okay. So this is the circuit given to you. In first glance, you can see that there are how many number of meshes? Please chat. Sir, to spot them are not able to please custom link. Uh, yeah, please, others. Yeah, four. Yeah, four. Now, where is the super mesh? Please answer. Where is the super mesh? I am sharing for 1 second. Let me link to another student. Others, please let me know where are the super mesh. That we will come to. Let me just mail this guy. Yes. So please in the chat, where does let us say this is mesh 1, mesh 2, mesh 3, mesh 4. So where does this means what is the how will you identify? Okay, here you have to create right in the chat how to identify that we where we have create the super mesh. Which meshes will be included in the super mesh? How will you identify that thing? Between 3 and 4. 3 and 4. Green is saying between 3 and 4. There will be another super mesh, means another mesh will be included. I have told that if there is a current source, I have not told anything whether it should be a source. Okay, this is a circle, okay, and there is an arrow inside the circle. So definitely this is a independent current source. But yes, 1 and 4 will also be there because it is also a current source. It's a dependent current source and it is a voltage dependent again this diamond like structure, okay, and there is an arrow in between, that means dependent current source. And if we see just beside it, it is written 0.2 V0, and V0 you can see it is given as a voltage drop across this 10 ohm resistance. If that is the case, then it is a voltage dependent current source. Okay, so this voltage dependent current source is a common between mesh 1 and mesh 4. Certainly, you have to also create a super mesh. The super mesh will consist of mesh 1 or mesh 3. Okay, this structure. So, okay, mesh 2 will be okay. There is no common, there is resistance here, there is a voltage, dependent voltage source here. But this mesh 1, mesh 1, mesh 4, and mesh 3, this will be combined as a super mesh. Okay, because in between there were current sources. If that is the case, let me just
Recording in progress.
Yeah. So first you can write the KVL equation for mesh 2. Okay, there is no concept of super mesh here. You have to just write the KVL equation for mesh 2. In mesh, again, you have to go in clockwise direction. So for the first thing, you have to first identify the meshes that we have already done. Next, you have to assign an unknown current. This is mesh 2. We have numbered it as mesh 2. So we are assigning I2 for mesh 2, and we are considering that I2 will be flowing in clockwise direction. At the end, we will see whether our assumption is right or wrong. Okay. Yeah. So then let us, if we start from this 10 ohm resistance, okay. If we start from this 10 ohm resistance, then if I2 is flowing, again, there will be two currents. So this 10 ohm resistance, there will be two currents. If you see this 10 ohm resistance alone, so this is 10 ohm resistance. In this direction, it will be I1. Okay. In this direction, there will be I2. Okay. Top to bottom, there will be I1. Bottom to top, there will be I2. So how to in which direction you have to consider the net current to flow? The net current will flow in the direction where the current is higher. But both I1 and I2, 1 minute, switch on the fan. So both I1 and I2 are unknown. So I have already told you that if you are considering a particular mesh, you have to consider that you have to assume that mesh is the highest among all other currents. Don't, then what is the problem? That also we have. So since we are considering mesh 2, we will be considering I2 is greater than I1. So the net current will be flowing in this direction. And if you have any fun talk, otherwise keep it muted. So the net current will be flowing I2 minus I1. Okay. And it is in which direction? Bottom to top. So definitely this will be plus sign, this will be minus sign. Okay. So if you are considering this, if you are moving in clockwise direction, then you will be encountering the plus sign first. So plus 10 I2 minus I1. Okay. Then you are if you move in the clockwise direction, the next element will be the 10 ohm resistance. So 10 ohm resistance, in what current is flowing there? Only I2 is flowing. I1 was flowing in this direction. So I2 is the only current flowing through this 10 ohm resistance. Okay. So what is the direction from this left side to right side? Left to right side. So plus sign will be on this direction and minus will be on the other. As a result, if you move in clockwise direction, you'll be encountering the plus sign first. So plus, what is the value of the resistance? 10. And what is the current flowing? I2. That means we are writing the voltage. Next, the next element will be this one. Okay. Here you are encountering the plus sign first. So plus, and it is a voltage. Okay, 4 multiplied by I0. We don't know what is I0, but it is a voltage source. So plus of 4 I0, that will be equal to 0. So this is the like KVL equation for, this is the KVL equation for mesh 2. You can further simplify this 10 I2 and this 10 I2 will be 20 I2. Okay, 20 I2 minus 10 I1 plus 4 I0 should be equal to 0. So this one 20 I1 minus 10 I2 plus 4 I0 will be equal to 0. Next, you have to, the only other mesh, all the other three meshes you have to consider as a super mesh. So there will be a single equation for super mesh. How to write that equation? Again, whatever current has been assigned, you have to, when you are considering a particular mesh inside, but have to consider only the current that you already considered there. Assume, let's say Again, let us start from here. You are moving in clockwise direction, in this direction. You are moving in this direction, let us say. Then we are encountering this. Let us start with this voltage source. Okay. Then if you move in clockwise direction, what is the sign that you are encountering? Plus minus sign. So minus 100 volt. Minus 100. Then in moving in clockwise direction, you will encounter the 50 ohm resistance. In 50 ohm, the only current that is flowing, that is the I1. No other current is flowing. Based on our assumption, no other current is flowing. So only I1 is flowing. So and I1 is moving from left to right. So plus sign will be on this side, minus sign will be on this side. So if you are moving in clockwise direction, you will be encountering the plus sign first. So it will be plus 50 I1. Next, in the next element is 10 ohm resistance. In the 10 ohm resistance, both current are flowing, I1 and I2. But since you are writing it for, let us say, mesh 1 or the super mesh, then we'll consider that I1 is greater than I2. So you'll be writing it as and I1 is greater than I2. So net current will be flowing in this direction from top to bottom. So plus sign will be here, and minus sign will be on this side. So if you move in clockwise direction, it will be plus 10 I1 minus I2. Next, clockwise direction, the next element that we will encounter is this voltage source, and you will encounter this minus sign first. So it will be minus 4I0. Again, moving in clockwise direction, the next element you will encounter it is this 40 ohm resistance. Is this 40 ohm resistance? But what is the current flowing through this 40 ohm resistance? That is I3, and I3 is flowing. The only current that is flowing through this 40 ohm resistance is I3. That based on our assumption may be wrong. But till now the assumption is I3 is flowing through this 40 ohm resistance. So as a result, it is flowing from top to bottom. So plus sign will be on here, minus sign will be here. So plus, if you're moving in the clockwise direction, you will encounter the plus sign first. So it will be plus 40 I3. Again, moving in clockwise direction, the next element you will encounter, again, you will encounter the 100 volt that we have already considered. So that completes our equation. That completes our equation. So you can just simplify this. Okay, this 100 ohm you can take on the other side. Again, 50 I1 plus 10 I1. So it will be 60 I1 minus 10 I2 plus 40 I3 minus 4 I0 is equal to 100. Okay. Fifty I1 plus 10 I2. Okay. Minus 4 I0 plus 40 I3 will be equal to 100. This is the equation in the super. What is, we have two equations. One was for mesh 2 and another for super mesh. But how many number of unknowns? 4 unknowns are there. Okay, and also there is I. Okay, so we have to do something about. Okay, then what we are, then let us write KCL equations. Okay, so at point A, at this point, let us write equation. Now we have to make out more equations so that you'll be able to solve. That means to get a unique solution for this I0, I1, I2, or I1, I2, I3, I4, you have to, so that you have to able to solve. So if you apply, let us say, this KCL equation at node A, that means KCL. What was KCL? Someone write in the chat. What was the someone write chat? What was the basic idea of KCL? Incoming current equal to, okay, yes, correct. So apply KCL at node A. Okay, it is a node interconnection of 50 ohm, 10 ohm and 10 ohm resistances. So interconnection of two or more elements. So A is a node. So you can apply this KCL equation here. So what is the incoming current that we have considered? That is I1. So incoming current means minus. You can write it otherwise also, means other convention also, but we have done in class. In minus, outgoing means plus. So minus I1, it is incoming to node A. Again, I0 is outgoing, so plus I0. Again, I2 is outgoing, so plus I2. That will be equal to 0. So you can write I0 is equal to I1 minus I2. That you can write. So this is giving us a relationship between I0, I1 and I2. Okay. Now you can, instead of using this 1 and 2, you can, if you put this I0 here, if you put this I0 here, so it will be 4I1 and minus I2. So the whole equation, the equation we have got for KVL, that whole equation will be a function of I1 and I2. So that is what it is written here. That means I1 will be 16 by 6 divided by I2. There is a direct relation between I1 and I2. So here also, I0 is there in super mesh. Whatever equation you have got, this I0 you can replace from here, I1 minus I2. So you have removed I0 here. So the whole equation will be a like a function of I1, I2, and I3. I0 you have removed. So if you do that, the whole equation will be simplified like this: I1, I2, and I3. 28 I1 minus 3 I2 plus 20 I3, that will be equal to 50. Okay, you can take common something and it will be cancelled out. So 50 you will be getting. Okay, now let us go back. This one, what you are seeing, just see this part. See the current source between mesh 4 and mesh 3. Okay, between mesh 4 and mesh 3, there is a independent current source. So like this, it is 2 ampere. Now, what are the assumptions we have done? That I3 flows like this. So this will be I3. And I4 flows like this. So this will be I4. Okay. So I4 is moving in downward direction and I3 is moving in upward direction. But the current source itself is showing, okay, the net current that it is flowing, it is, the magnitude is 2 and the direction is bottom to top. Then definitely this I3 thing should be greater than I4. Then only the net current will be flowing in bottom to top. Otherwise the opposite thing would have happened. So you can say that I3 is greater than I4. Okay, based on the direction of this current source, and the difference between I3 and I4 is will be 2 ampere. Okay, so you have got a relation, use this relation here. Okay, I3 and I4, that will be equal to 2. Similarly, out this dependent source. This dependent source, this dependent current source, it looks something like this. Okay, now we have considered that I1 flows like this. So I1, this is I1, and I4 flows like this. This will be I4, but the direction of the current source, dependent current source, is given in bottom to top. So definitely this I1 should be greater than I4. Then only this direction of the current can be possible. So I1 is greater than I4, and I1 minus I2, that will be equal to this 0.2 V0, 0.2 V0, the net current. What is the magnitude of the current? Now V0, you can write it as, so from this what you are getting, I1 minus I2 will be 0.2 V0. Now V0, it is shown in the circuit. V0 is a voltage in some other part of the circuit. V0 is the voltage across this 10 ohm and the direction is also given. This side is plus, this side is minus. Now what we know, I2 we have considered here. So I2 will be flowing in this direction. So if you consider only this 10 ohm resistance, let us say this one, and what has been given, this is V0. We don't know what is V0. Okay, this is 10 ohm. What we have considered, okay, I2 current flows like this. If it is clockwise direction, then V0 will be nothing but 10 multiplied by I2. V0 will be nothing but 10 multiplied by I2. So that thing you can put it here. That means this equation, I1 minus I2 0.2, and in place of V0 we can write 10 I2. So we are writing it as 10 I2. So I1 minus I2 is equal to 2 I2. Okay. So I1 will be equal to 3 I2. So the direct relation between I1 and I2 also you have got. So with this many able to solve all the currents. These are the bits of analyzing any kind of super mesh. Now, based on this relation, if you put it in the equation of super mesh and KVL mesh 2, you will be able to find all the values of current. I2 will be this much, I0 will be this much, what will be I1, I2, using all this equation, you will be able to find. Okay. Now, I am keeping this circuit for a few minutes, let us say. Let me maximize this. And let me know where are your queries are. Okay, this is the last mesh. In this theory class, this is the last problem will be solved super mesh. So let me know what are your queries. We'll solve many problems. In tutorial also we'll solve some problems based on this. But yeah, theory class, this is the last we are doing. Based on this, because just now this super node will also come, so things will become bit like complex from now on. Please, if you have any doubt in this circuit. The equation for the super mesh can be multiple unknowns. Now, what are the next equation? Next, you have to see that what are the current, each and every current. Okay, we did for this independent current source, for like we did for dependent current source. For each of these current sources, you can write their own equation. So these current sources are common to both the mesh. That's why we are writing this equation. Since they are common to both the mesh, and for each and every dependent source also you have to write another equation. Okay, so using all this to solve this problem. Okay. See, if you have any doubt, let me know. Otherwise, we'll move to the next section. Not this one. We'll be moving to the nodal analysis. Okay. Still, if you have any kind of doubt, okay, please let me know. Next is nodal analysis. Now in mesh, what was the first step? The first step was you have to identify the number of meshes. Okay, whether you have done it correctly or not, you can just verify it by using the formula that we have designed as the number of nodes plus 1. So in that way, without whether you have correctly identified all the meshes or not. Next, the next step will be to the mesh that you assign one unknown current to that mesh. Okay, one you have assigned I1. For mesh 2, you have assigned I2. In this way, you have identified all the meshes clockwise direction. That is the convention we have considered that okay, whatever current in clockwise direction, but it can be the opposite also. Consider it as anti-clockwise. consistently use that. Otherwise, it will be difficult. And then you have assigned some unknown currents to each and every mesh. The next step, take each and every mesh and write the KVL equation for each mesh. Okay. And then you can solve those equations. There will be unknown. After solving the equation, find out what are these. So mesh analysis was to find the unknown currents in different mesh. The next is the nodal analysis. First step in nodal analysis is how many number of nodes are there. Number of nodes are there. Then what you have to do, you have to assign unknown voltages to the nodes. Okay. Is to find out what are the values of this unknown voltage. So given this circuit, okay, given this circuit, number of nodes are there. This is the circuit given to you that yes, it is already and it is written 1, 2, 3, 4, 5. That okay. This is not okay. This is not a node. Okay, that you have to add. This is not a node because here this voltage source here there is no element. So the definition of any node or junction point between two more elements. But this particular, if you are seeing that okay, saying that this cannot because there is no element here. Again, is this a node? No. RB, this can be is there, VA is there. Means a node. Okay, but the reason why we are not considering this, these two, there is nothing different between these two nodes, this node and this node. So as a result, we are considering this as a single node because between this node and this node, there is no element here. So we can consider nodes are same. Okay. Now the next step will be to assign. So again, how many numbers you have to assign the node voltages? Nodes you have identified. Now you have to assign some unknown voltages. You know what potential this node is sitting at. So you have to assign some unknown ones. Let us say you are assigning voltage V1 to this, V2 to this, V5 to this, V4 to this, and V3. All these are okay. Voltages. How many number of nodes? Nodes minus 1. The okay. Okay, so you are asking V1 node, let us say V1 to 1, first node, V2 to second to third node, V4. But among all this reference voltage. Okay, reference voltage will already also means we will consider it as 0. Okay, so we are fixing a value to 1 is 0 volt. Okay. For all other nodes, you have to assign some node. So here, let us say this third node as the reference node. So here, third node will be grounded. That means it has 0 volt, so grounded you can consider. For all other nodes, you have to assign some value V1, V2, V4, V5. Now, the reason you should ask, so why not this fourth node, the ground node? It may look like this. The circuit may look like this. This is the voltage source. This is RA. This is RC. This is RE. Again, plus minus. Okay. This is, let us say, V4. this is V1, this is V2, this is V3, and I have told that, sorry, this is V5, and this is V3. So I've told you that V3 we are considering as 0 since it is the reference node. Okay. Thus will be written in comparison to the this V3. So V3 we have 0. That means V1, let us say 2 volt higher than V3. So V1 will be a 2 volt. Say it is 2 volt. So V2 will be minus 2 volt. In this way, you will be able to find V1, V2, like V1, V2, V4, and V5 values. Now, you may ask that why didn't we consider this node to be grounded? In the same case, considering one of the nodes to be at ground and the other nodes, we consider some unknown voltage, and through mathematical manipulation, we will be able to find what are the values of those. Is why V3? Why not the first? Let us say this is the fourth node. Why have you not considered the fourth node as the reference node? So can someone give the answer? What is the difference between the third node and all other? Just by seeing, you will be able to find the difference between uh, uh, which date to be the reference. Please,
Plus,
just see the
same, there will be same potential on what the
but that part. That's why you are combining it as you are saying that okay, here there will be no voltage drops. That's why. But we have already not considered. Let us see. You have already considered all these to be a particular node. That this one we are representing as this one. But for the way we have considered the nodes, we have considered all these to be a single node. Again, the answer lies here. What is the difference between and all other nodes? So here, which node to choose as a reference? The answer is the node with which, okay, that you have to consider as that node you have to consider reference node. Why? The reason will be very clear. That means more number of branches, number of terms will be there in your KCL equation. To avoid that thing, the node with which maximum number of branches are connected, that node we consider as the reference node. It makes our job a bit easier. Here, let us see the fourth node. How many number of branches are connected here to the fourth node? This branch and this branch. Okay, so two number of branches are there with the fourth node. How many number of branches are connected with V1? 1, 2, 3. That means 3 branches. How many number of branches will be connected to V2? Again, 1, 2, 3. So 3. How many number of branches will be connected to this node? Fifth node? One branch, second branch. So 2 branches. And what about the third node? Branch 1, branch 2, branch 3, branch 4. So 4 number of branches are connected to the third. We are considering this third node to be the reference node. Use the number of terms that you have to consider. Is it clear? If with the same number of branches, then you can choose anything. Any of the nodes you can consider as reference. If there are multiple nodes with the same number of branches. Is it clear? So the thumb rule is node as a reference node on which maximum number of branches. Okay, so that will be the reference. So this is another problem. What you can do now from all these nodes, the nodes has been identified. This is also a node. This is also a node. This is also a node. Okay. Interconnection of two or more elements. Now, among these criteria for selecting the reference node, see the third node here. The third node, maximum number of branches have ended here. So that's why we are considering this as the reference node. Reduce the computational burden. Okay. Then now it happens to V4 and V5. Here, fourth node was there, fifth node was there. Now you are not seeing. Okay. So the maximum number of nodes that you have to consider that was given here. Okay, that is the number of node voltages, number of nodes minus 1. Okay, so this is the maximum number of node voltages. Definitely you can try to work with less number of node voltages. That means number of unknowns, less number of equations. Let us consider, because the reason is why we can neglect this node, because if you neglect, okay, don't consider this node, you are considering this node, then this R2 and R1 are nothing but in series. So you can simplify this. You can just two resistances with one equivalent resistance R1. If you do that, let me draw this. That means there this R1 was there and this R2 was there. There is this current source. R3 is there. R5 is there. R6. R4. So what we have understood, okay, this we have taken as the reference, that is the ground. Okay, now you see this. Okay, you can consider this a node, but what happens, just to simplify, why to write unnecessary equations? So can you replace these two things as a single resistance? That is the sum of R1 plus R2. Again, can you replace these two resistances by a single resistance? And the sum will be R5 plus R6. This you have already considered as a single node. So let us say this is node 1, this is node 2. What you are doing, you are applying an unknown voltage, that is V1 and V2. Okay, so the node voltage in the first node, voltage in the second node will be V2. Now you have to do the next thing, you have to write KCL equation in each and every node that you have identified, like unknown voltage. For each and every node, you have to write the KCL. How to equation? Let us first start with this node, first node. Okay, so V1 is the unknown. Let us consider this branch. KCL means you have to identify, you have to see that are coming in and out of that node. We are considering the first node, this one. We are considering the first node. Okay, and we are trying to see that what are the currents that are entering this first node, what are the currents that leaving the first node. Now there is a current source already there, I1, and the direction is given. That means the current is going into the first node. So if the current is going into the first node, there is already given that current going in, that means minus I1. So for this branch, you have written what is the current flowing in into this first node. What about this branch? Now this branch, you have to see that what are the different currents that are coming in and out of that node. We are considering the first node, this this one. We are considering the first node. Okay. And we are trying to see that what are the currents that are entering this first node, what are the currents that leaving the first node. Now there is a current source already there, I1, and the direction is given. That means the current is going into the first node. So if the current is going into the first node, that is already given, so you cannot do anything. You have to just write that current going in, that means minus I1. So for this branch, you have written what is the current flowing in into this first node. What about this branch? Now, this branch you don't know. This is grounded, but you don't know V1, the value of V1. V1 can be greater than 0 volt. If V1 is greater than 0 volt, then current will flow here. Current flows from higher potential to lower potential. So if V1, let us say V1 is greater than 0 volt, then the current will be flowing in this direction. Opposite thing may happen, that V1 is less than 0 volt. That means the current will flow in this direction. So what, again, some kind of an assumption you have to take. Assumption may be wrong, assumption may be right, but one assumption you require. That means if you are considering a particular node, the voltage of that particular node, you should consider that it is the highest one. That means then if you consider that, then V1 is the highest voltage among all other nodes. So what are the other nodes? 2 is a node, 3 is a node. So 3 we have already considered as 0. So V1 should be greater than 0. Again, V2 we don't know, but whatever be the value, V1 should be greater than V2. So this we consider while writing the equation for node 1. So for this branch, you have written what is the current going into the node, so minus I1. For this branch, you have considered that the highest voltage is at node 1. So if the highest voltage V1 is greater than 0, definitely current will be flowing in this direction from the bottom to top. Okay. So what is the current that will be flowing? We don't know what is the current value. So current, but the direction we know. The direction is coming out of this node. So definitely it will be plus. But what will be the actual value? The voltage that we have considered V1 divided by the net resistance, again coming from V equal to IR. Okay, or I is equal to V by R. So in the numerator, we are writing the voltage first. Voltage is V1 minus the voltage at the ground, that is 0, divided by the resistance R1 plus R2. So we have written the equation and plus sign because it is coming out. Again, for this branch, for the R3, the branch with the R3, what we can consider? We have to consider that the voltage at our present node, that is the highest one, that is V1 is higher than V2. V1 is higher than V2. If that is the case, then current will always flow from higher to lower. So V1 will be greater than V2. So what is the current flowing? Again, V1 greater than V2. So current will be flowing in outward direction. So plus sign. And what is the magnitude? That is V1 minus V2 divided by, what is the resistance value? Resistance value is R3. So that will be equal to 0. Done. Please let me know if you have any doubts in this. That means we have written the KCL equation. Let me write it. KCL at node 1. We are writing KCL at node 1. See whether you are able to grasp this or not. If not, please raise in the chat. I will try to clarify more. Okay. Okay, so this you can further simplify this. That means V1 divided by R1 plus R2 plus V1 divided by R3 minus V2 divided by R3. That will be equal to this minus I1 and we're taking on this side. So that will be equal to I1. So the first KCL equation for this first node that we have already done. Now what about the second node? That is, can you write the KCL equation there? Can you write the KCL equation at node 2? The answer is given, but just see whether the concepts are clear or not. So KCL equation at node 2. So node 2 voltage will be the highest one. That's our assumption. So that is the case. What is the current flowing through this path? V2 greater than V1. So current will be flowing in outward direction. Okay, current will be flowing in the outward direction. So it will be plus sign. Plus sign V2 minus V1 divided by R3. Again, V equal to IR, I is equal to V by R. Okay, so this is the current that is flowing through this branch. Next, let us consider this branch. What is the potential difference across this branch with R4? In one terminal, V2 is being given and the other terminal has 0 volt. So definitely the current will be flowing from top to bottom. Top to bottom, the current will be flowing from top to bottom. As a result, what is the direction then? It is flowing in outward direction. So there will be plus sign. And what is the magnitude of the current? Voltage divided by resistance. So V2 minus 0 volt, V3 is 0 volt divided by R4. Okay. Next, the last branch, this branch. In this branch, what is the current flowing? Now, what is the voltage difference you have to find? V2 minus 0. One of the terminals of this branch is connected to 2. The other terminal is connected to 0. So V2 minus 0 divided by what is the net resistance? That is R5 plus R6. This will be equal to 0. This will be equal to 0. So what are the known and unknown? Here V2 is unknown and V1 is unknown. In the previous case, again, V1 and V2 are unknown. So definitely we will be getting, if you solve this equation, you will be getting some kind of an answer. Okay, that means some unique values of V1 and V2 you will be able to find. Okay, now let me know if you have any doubts here. Now we will be seeing different cases of node analysis, but before that, all your doubts should be very clear. Otherwise, it's difficult to then it will be difficult for you to understand the next concepts. Let me know in the chat. Let me bring the water. Just see whether you have any doubt or not. I am giving you the solution here. See. Yes. So from these two equations, we will be able to find out what are the values of V1 and V2. Two equations, two unknowns. Again, values of I1 and I2, all this resistance will be given to you. Okay, and I1 will also be given to you. In that case, we'll be able to find out. Okay. Now, let us see whether you'll be able to solve this problem or not. First, the nodes has been identified. So what are the nodes here? Again, this is a node. It's the interconnection of multiple elements. Okay, this is a node. Okay, and this is a node. So 1, 2, 3. 3 nodes are there. 3 nodes are there. Now you may ask, like, which one you will choose as a reference node. Which one will you choose as reference node? So the thumb rule is the nodes in which maximum number of branches are ending, that node you have to consider as this reference node. Okay, but if you count, okay, okay. Now you have to count how many number of branches are ending in that particular node. 1, 2, 3. 1, 2, 3. How many number of branches are ending? 1, 2, 3, 4. Okay. How many number of branches are ending at this? You can consider 1, 2, 3. So definitely V2 you can consider as the reference node or zero or ground. Okay. But if you don't do that, in that also case you will be able to solve this. We will show that part. But if you consider the node with the highest number of branches as the reference node, in that case you have to, the things will be simple. That means the number of terms in each and every equation, that will be less. If that is not the case, still you will be able to find out. Okay. So thumb rule is that it is not like you have to follow it every time, but if you follow it, it will make your life easier, the computation easier. Now let us consider that the this node to be the ground node. Okay, and see what problems you face or how you can solve this. Okay, then considering the first node for this node 1 first, what you are doing, you are assigning the unknown voltages. So V1 is assigned to first node, V2 is assigned to second node, and the third node you are here considered as grounded. Okay, so now what is the second rule? That if you are writing the KCL equation of node 1, then what you have to consider, that the voltage that you have considered for that particular node, that is the highest one. So it is V1. So consider this branch. What is the current flowing through here? Okay, consider what is the current flowing through this branch. Now this is at V1. V1 is the highest potential. This is at grounded. So definitely the current will flow from higher potential to lower potential. As well as the current will flow in the outward direction, the going out from this node. So it will be plus sign. What will the magnitude of the current? V1 minus 0 divided by 10. Okay, V1, this is V1 minus 0 ground divided by 10. Then again, consider this branch. This branch is again in one of the terminal it is V1, in the other terminal it is V2. Okay. Now how to find out in which direction current is flowing? The thumb rule is you have to consider V1 as the highest, because we are writing this KCL equation for node 1. The voltage at this particular node will be the highest one. So if you consider that V1 is greater than V2, then the current will flow from higher to lower potential. So in this direction current will flow. That means current will be going out of this node. That means again plus sign. plus V1 minus V2, that will be equal divided by 5. This is nothing but again Ohm's law, V equal to IR or I equal to V by R. Okay, that's what we are writing here. And this node, okay, this branch, sorry, this branch. In this branch, there is a current source. In current source, you don't have to see like voltage, what is the voltage, what is the resistance, because current source is itself giving the value of the current. That means 2 ampere is flowing into this node. So definitely the it will be minus because current going in a particular node. So it will be minus. Minus, what is the value? 2. This will be equal to 0. Okay. Now there are two unknowns, V1 and V2. V1 and V2 are the two unknowns. But single equation, two unknowns you cannot solve. So you need another equation. So we require another equation. For that, we have to write the KVL equation at node 2. KVL equation, sorry, KCL equation at node 2. Okay. Then when you are writing the KCL equation of node 2, you have to consider V2 to be the greatest or the largest voltage or the highest voltage to be of V2 to be of highest value. That means V2. Now, what are the different like branches? This is a particular branch. This is a particular branch. Now we are considering V2 is greater than V1. Okay, so the net current will be flowing out. Current flows from higher to lower potential. So current will be flowing out of this node. So it will be plus sign. And what is the value? V2 minus V1 divided by 5. Again, see this node. Sorry, see this branch. This branch, there is this 2 ampere current. The current is flowing out of this node. So it will be plus 2. Again, here, V2 is the highest. Okay, V2 is the highest. So V2 minus 0. V2 minus 0. So this is 0, this is V2. So this will have higher potential. The node 2 is at higher potential. So current will be flowing out of this node. So it will be plus V2 minus 0 divided by 20. And here in this branch, there is a current source. There is a current source and it is going out of the node. So plus 4. That will be equal to 0. Okay. Again, in this equation, two unknowns are there, V1 and V2. So two equation, this is equation 2. Okay. This is equation 1. So from this two equation, two unknowns you'll be able to solve. So based on this, you'll be able to solve the values of V1 and V2. 1 minute. So this will continue from the next class because next class is your tutorial of this subject. So here what we will do, I will be there in the class, but we also give a chance to your seniors. Okay, so now we will be introduced to one of your seniors. He is from 3rd year. Now there is a like a rule here, or rule means you can means volunteer to take these classes. Okay, like those who of you will perform better in this subject, you will be given the chance to take these classes for your juniors. Classes means only the solution. The problem sheet will be given to you. I will upload the problem sheet in the Google Classroom. The same list of problems will be there, and the solutions will also upload, but those will be explained by your seniors. Okay, the same chance you will also get when you will go to the third year. The chance you will get the chance to teach your like first year. Okay, and you will be paid for that. For each and every class you will take, for the each and every class you will take, you will be paid for that. I will also be there, but the problems will be there, and he will try to solve those, and he will try to explain. And he has performed well in this subject. That's why he is given the chance. So this we will follow in the only the in the tutorial classes. In normal theory classes, I will be taking the whole thing. So from this point, we will again continue tomorrow. Next will be some problem sheet will be there. The problem, it contains the problems that of the topics that we have already covered, the basics. Okay. So yes. So please introduce yourself. Uh, Let me just stop the sharing. I think you can come here. Yes. Just introduce yourself.
Hello class, myself Bharat Chandra. I'm currently in my third year CSCID department. I've secured A plus in fundamentals of electronic engineering. So for this entire sem, I will be taking tutorials for you.
Yeah. Okay. So tutorials. 1 minute. Let me download the tutorials first. I've sent it. Solution you have in your mobile, na? Solution just that I'm not sharing. So both the tutorial sheet and the solutions will be uploaded in Google Classroom. Okay. Just you here he will be showing the steps. Which steps you have to follow to solve that. That will be shown here. Yes, I think everybody can see this. I have shared this. So this is like a tutorial sheet. It contains 8 problems. Okay. Starting from the basics and going till mesh analysis and nodal analysis also. He will give you the step-by-step solution. The brief solutions will also be shared in Google Classroom. Okay. So yes, please. So you have to write it. You have to start a PowerPoint and okay. Here you can write. See, and Classroom. Just delete these things. And now write here. Yes. Yes. Like this, he will write and he will give you the step-by-step solution. Okay. Put in the class. I will come to take the attendance. Okay. At around 5. Okay.
So all of you please reply whether you have got your tutorial sheet. Only 12 students. Anyone please reply? Guys, okay, if you haven't got, I will be showing the tutorial sheet here and I will be solving step by step, okay? So the first question is the charge entering a certain element is shown in the figure 1.1. So we have to find the current at time t is equals to 1 millisecond. So we know looking into the diagram at t is equals to 1, we have to find the current. So we know current is equals to rate of change of charge. Okay. So here we are given with the charge versus time graph. So at t is equals to 1, we have to find the slope from 0 to 2 so that we will be getting the current which is passing through that particular element. So here we have current is equals to change in the slope 30 minus 0 divided by 2 minus 0. 30 minus 0 divided by 2 minus 0. 30 divided by 2. 15 ampere is the current passing through the specific element at time t is equals to 1 millisecond. Am I audible? Can anyone share? Yeah, if you want to try, then okay, you send me the answers in the chat. If any doubt, then I will solve that. Okay. Reply in the chat. Okay. How can I even know whether you are getting? Okay. Okay. So try for t is equals to 6 millisecond and type your answers in the chat. I will be seeing. Okay. 0. Okay. Yeshwardhan Chauhan. Answer 0. More answers. More answers. Zero. Okay. So I've got two answers to be 0. So can anyone explain why it is 0? Rajveer Rajwat. Rajveer Rawat. No increase in charge. Okay. Nice. Yes. There is no change in the slope. So the current passing through that element is 0. Nice. So now let's move on to C where t is equals to 10 millisecond. So solve this. Okay. I'm looking into the chart. Minus 7.5. Okay. One answer. I'm expecting more. Two more. Okay. Yeshwardhan, it's not a 7.5. It's minus 7.5. So I will be explaining. Okay. See, it's like You have a negative slope over here. So you have to consider 0 minus 30 divided by 12 minus 8. So it's like 0 minus 30 divided by 12 minus 8, like minus 30 divided by 4, minus 7.5. Right? Is it clear? Okay. Only 2 students are always replying. I want more response. Okay. Moving on to the second question. The current through an element is shown in figure 1.2. Determine the total charge that passes through the element at t is equals to 1. Answer 10. Arun Agarwal. Okay. We have to write it with the units also. 10. Quick. Then she. Nice, 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 nice. I'm only seeing 3 to 4 names at 12 participants. Yeah, it's like basic 12th class physics, current electricity, right? Yeah, so can anyone explain how did you solve? What methodology have you used to solve this? You can't unmute or what? Yeah, nice area under the curve. Yes, yes. Yeah. Arun Agarwal, can't you unmute? Okay, let's move on to option B. T is equals to 3 seconds. Calculate the area under the graph till 0 to 3. Okay, okay, it's fine. If mic is not working, it's fine. Okay. So post me the answer of B. Second B. T is equals to 3 seconds. 22.5 C. Okay, okay, okay. More answers, more answers. Okay, okay. Yeah, if anyone are facing any doubt, I'm ready to explain. Okay, please let me know in the chat. Is it clear? Yes, yes, yes. More. Is it clear, everyone? Okay, okay, okay. So let's move on to C. T is equals to 5 seconds. Yeah, only the major point you have to remember is that we have to calculate the total area under the graph from 0 to 5. Okay, 30, 30. Okay, right, right, right. More answers, more answers. Not 25C, it's 30C. 30, 30, 30. Yes, sir, then is it clear? It's not 25, okay? Should I explain or what? Should I explain? Okay, okay, okay. Okay, I'm moving to third one. Okay, to find the power absorbed by each of the elements in figure 1.3. So here you have to know the basic power formula. P is equals to voltage into the current to that specific element. So try we have P1, P2, P3, P4, P5. So post your answers like P1 is equals to this. Yeah, yeah, yeah. Okay, nice. P2, P2. Okay, 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 okay. So the only confusion which you are getting is like plus or minus sign. So C current will always go from positive to negative. So C for P1 it's going from negative to positive. So we have to use the minus sign for current. So minus 10 into 30 minus 300. Okay, minus 300 watt. Also consider this sign. No one are looking into this sign. Okay. So we have got P1 is equals to 30 into minus 10 minus 300. P2 10 into 10 100. And for P3 it's 14 into 20 it's 280. And for this 4 into minus 4 into 8 minus 32. Yeah, right, minus 32 minus, yeah. And see here you have 0.4 into I. So here I is predefined. I is equals to 10 ampere. So 0.4 into 10 is equals to 4. 4 into minus 4 into 12 minus 48, not 48. Most of you have put 48. So look into it. So this P5 thing is a bit trickier. Okay. Don't confuse. The I value will be given in the question only. Okay. Is it clear? At least 2 to 3 yes. 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 Is it clear? What is P5? So P5 is 0.4 into I value is 10. So 0.4 into 10 is 4. 4 into minus 4 into 12 minus 48. Okay. 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 I'm moving to the fourth question. So this is basic fundamental question. So solve this fourth question. You can solve this in just 5 seconds. 5 seconds. 6. Okay. One answer. So for this, you can also provide that explanation in this why I've got 6. It's one line answer. So please provide me the explanation for this also. ACL. Okay. 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 More answers. More answers. Yeah. If you all guys answer quickly, then we'll end the session in just 15 minutes. All questions will be completed. Okay. You answer quickly, we'll end the class quickly. Okay. Is it clear? 6A, 6A. Okay. Okay, okay. I've got 4 to 5 replies. Okay, it's fine. So moving on to the fifth question. Find V naught and the power absorbed by each element in the circuit of figure 1.5. Okay, solve this. So I will be giving 2 minutes for this. You put your answers. If it's not understandable, I will explain this. Okay. So take your time. Your answer should be like for 30 volt, the power is this much. For 12 volt, the power is this much. V is equals to 18. Okay, okay. Only two answers. Okay. Should I explain this? Anyone? Should I explain? Okay. I will explain. So if you guys have this, open this, or else you draw this. Okay, circuit. I don't know whether you have got this or not. If not, you can draw it. Okay. So I'm getting into the explanation part. So now let us see. To see for this 30-volt power supply, we are going to calculate the power. So first, for 30-volt, it's like 30 into minus 6 is equals to minus 180. We have taken minus because the current is going from negative terminal to positive. So we are taking minus 6 into 30 is equals to minus 180 watt. Okay, that's for power source 30-volt. And power for the 12-volt element, that is 12 into positive 6 is equals to 72 watt. Yeah, we are done with this 30 and 12. And we'll be going to 28, and we not. Okay. Now going to 28 volt. It's like 28 into 2 is equals to 56 watt. And we also have another 28. So 28 into 1 is equals to 28 watt. And we have V naught. Okay, we have to find that, and 5 I naught. Okay, so that is a dependent source. So for this, we will be taking 5 into 2 into minus 3. Because see, we have I naught value is equals to 2. Okay, and the current passing is equals to 3. 3 into minus 2 into 5. That is minus 30 volt. Okay, we have calculated the power for all 5, but we have left V naught here. So here we have to follow this rule. The power absorbed by all the elements in any circuit is equal to 0. So first we'll add up all this power which we have got. So by adding up all these powers, we'll be getting a total of minus 54 watt. Okay. And here we are having 3 into V naught is the power which is going through this V naught source. So 3 into V naught is equals to plus 54 is equals to 0. No, minus 54 is equals to 0. So here from this we'll be getting V naught is equals to 54 divided by 3, that is 18 volt. So we have got V naught is equals to 18 volt. Is it clear? Clear. Okay. So the only law we have to follow is the sum of all the powers inside a circuit is equals to 0. Okay. I will move on to 6th question. This is a bit interesting question. So you have to draw a graph for power, and then you have to find the total energy and all this. Okay, E is equals to 600 joule. Let me check out. E is equals to 600. Okay, okay. More answers? Reply me. Are you solving this or should I explain this? Aren't 600 is not the right answer? Once check your answer. Are you guys solving or should I explain? Reply in the chat quickly. Okay, okay. Second part. Okay, so to solve the second part, first we have to draw the graph of power from the first part. So I will draw the graph and I'll explain it. Okay, I'm going to explain it. Okay. Okay, so look into this question. So first we'll be drawing the graph for this power using this current and voltage graph. So see, for your reference, I'm drawing this current and as well as this voltage graph here. This is per ampere into time. That is like a triangle with maximum peak at 2 and this is 0 and this is 4. And the maximum current we're getting is 60. And similarly for voltage, we have volt, time, and sorry, we're having 0, it's 2, it's 4. And the maximum is 5. This is minus 5. So from this graph, we have to use this equation. In maths, we have seen this, right? Y is equals to mx plus c is the equation of the line. So here we have to divide this current graph into two parts where on the basis of time, so 0 to 2 is 1/2 and 2 to 4 is 1/2. So similarly, that has to be done with this voltage also. So I'm going to write these equations. So for current, the time that is, so first interval that is from 0 to 2, and the other interval is from 2 to 4. So we have two intervals. So see here, so for in the interval 0 to 2, it's like y is equals to mx plus c. You have to use this equation. So the slope of this can be calculated by 60 minus 0 divided by 2 minus of 0. That is equals to 30. Okay, so m ka value is equals to 60 minus 0 divided by 2 minus 0. That is equals to 30. It's a positive slope. And for calculating the value of c, as this line is passing, see, as this line is passing through the origin, you can take y is equals to 0 and x is equals to 0. So the value of c is equals to 0. So you've got the m value. So for the value of current in this interval of 0 to 2, you will be getting the equation of line to be 30 t. Here x in this graph, we are taking x-axis time. So we will be taking 30 into t. So, and for secondly, for this interval in 2 to 4, this same equation has to be applied. And here the slope is 30, but it's negative slope. So minus 30. In the place of x, we'll be taking t. To calculate the value of c, again, we have to use this. Like, as this is passing through the point, y is equals to 0 and x is equals to 4. So substitute the value over here, 4 plus c is equals to 0. You'll be getting c is equals to minus turns into plus, so 120. So c is equals to 120. So you have got this. So substitute all the values in the equation. So you will be getting 120 minus of 30t. Okay. You have got this equation for current. Now, similarly, we'll be doing this for the voltage. We'll be breaking down this graph into two intervals. This is one interval and the other interval is this. So see, this is not as complicated as current. Here we are having only one highest voltage, that is 5, and the lowest voltage, that is minus 5. So in the interval of 0 to 2, the maximum voltage it is reaching is 5, and in the interval 2 to 4, the maximum voltage it is reaching is minus 5. So that's it. You have got this. Okay. Is it clear? Till now, is it clear? Okay, okay. So we know that power is equals to V into I. So to get the same equation as this for power, we have to multiply the value of I into value of V. So both of this has to be multiplied to get the value of P. So for power, we'll be getting 30t into 5, that is 150t, and minus 5 into 120 minus 30t. So minus 5 into minus 30 plus 150t minus 120 into 5, 6. So this is in the interval of 0 to 2, and this is for 2 till 4. Is it clear? So on the basis of this, you have to draw a graph for power. So I'm erasing this to draw the graph of power now. So this graph will be like this, starting from 0 and interval 2 and another interval like this, starting from this. And this. Okay, is this graph clear for everyone? Yes or no? Yes, okay. If this graph is clear, you can easily solve both the questions. So once we'll be going back to the question. So note this graph down and this equation so that you will easily be able to solve this question again. Okay, I'm going sketch the power delivered to the element for t greater than 0. So okay, we have sketched the power for this. So This is clear. Now going into find the total energy absorbed by the element for the period. So now see what is energy for this graph, power and time graph. How can you calculate energy for power and time graph? Anyone in the chat, please. Power divided by time. Is it correct? Energy is equals to power into time. Okay. Yeah. Energy is equals to power into time. So here we have to integrate. Integration means the area under the curve. We have to find the area under this curve to get the energy value. Yeah. Integral P dot dt. So what does integral mean? The area under the graph. So calculate the area under this graph. So the magnitude which is above the x-axis is same as the magnitude below the x-axis, and both are having different signs. So plus of the same value minus of the same value will be giving us a total of 0. So the energy for this question is 0. Is it clear? So see, this y coordinates are 300 and this is minus 300. So calculate both triangles area is equals to half into base into height. Okay, the base is 2, 2 gets cancelled in both cases, plus 300, and this is minus 300 is equals to 0. So the total energy which we are getting for this is 0. Clear? Okay, 2s. Is it clear, everyone? To solve the seventh question. So I think this topic is also already covered in your class. So just solve it. V naught is equals to, okay, question 8. Okay, one reply I've got, and others please respond. Others say yes or no. Only Arun Agarwal has responded. What about others? Yeshwardhan, should I solve this or no? Okay, I will solve. Uh, So I'm reading the question. Using nodal analysis, determine V naught in the circuit in figure 1.7. Okay, using nodal analysis. So we have to find the nodes. So see here prominently we can see two nodes, one in between of 20 ampere resistor and 10 ampere, and the other is just after the 10 ohm resistor. So I will be drawing this circuit again. So see, plus minus. So this is one node. I'm naming it A, and this is I'm naming it B. Okay. Now we have taken two nodes A and B. Okay. So at node 1, so I'm applying KCL at node A. So see at node A, VA minus, so this voltage which you're having is 40 volt. So VA minus 40 volt divided by the resistance. So we know that current is equals to voltage upon by resistance. So I'm doing the same here. Voltage VA minus 40 divided by the resistance which you are getting is 20, this plus VA minus VB divided by the resistance is 10. This you have 10, this you have 20. Plus we also have this uh, VA minus V naught divided by 20 for this part. So this is the one equation which you have to solve, and this is for node A. And for node B, we have to apply the same. That is VB minus VA divided by 10 plus VB minus, you have to go this side. Here it is grounded, right? So VB minus grounded and yeah, so VB minus 0 divided by this resistance value is 10 ohm again. So 10 plus, for this current source we are having VIX. So this is in the opposite direction and we are going this way. As this source is opposing the current we are following, so we have to take minus 4IX is equals to so by solving both these equations, you will be getting the answer for this. And the value of Ix is also given. So you solve both of these equations and you will be getting the value of V naught. Yes, sir. Then is it clear? Did you understand how did I write both these equations? So this diagram might not be clear, but see, I have also already provided with this tutorial sheet. So one check there, it will be clear. Okay, yes. So Ashwardhan, you solve this and put the answer in the chat. Right. Understood. कुछ एक्स्ट्रा स्टूडेंट्स होगा उसका नाम नहीं पता तो मुझे दे दीजिए ओके सर Okay, one answer from Arun Agarwal, 60 volt. Okay, it's right. Yashwardhan, once confirm, is it clear again? Okay, nice. Now moving to eighth question, the last question of this tute, okay? And after this, I will be taking the roll call. Use a mesh analysis to find I1, I2, I3 in the circuit of figure 1.8. So once confirm, is mesh analysis done in your classes? Can do this, okay, one answer. Okay. Okay, if it is done, first you give me the answers for this, and at least 2 to 3 of people just give me the answers for this, then I will be taking the roll call. So only one answer I've received from Arun Agarwal. Okay. Same answer. So what about Yashwardhan? Is it clear? Can you solve this? Okay. Assignment or separate? Yeah, assignments will be different and tutorials will be different. For tutorials, I will be explaining, and assignments you have to solve this. Okay. So Yashwardhan, I'm waiting for you. Same. Okay. So there are total 12 participants. So all of you send your roll number in the chat box. I will be marking your attendance here.